Hey y'all, so welcome to density calculations. So let's take a look. We have a problem over here. A piece of copper has a mass of 948 grams and a volume of 106.3 cubic centimeters. What is the density of this piece of copper? All right, so right away, I underlined what I had, and then I boxed what I'm looking for. So I'm looking for density. So what's the formula for density? So density equals mass over volume. So I'm just using the variables m and v to represent mass and volume here. So next thing is we're going to try to see if we have those variables. So do we have our density? No, that's what we're looking for, right? That's what we box. Do we have our mass? Let's take a look. So some units for mass, grams, milligrams, kilograms. Do we see that in the problem? Yeah, we do right there, right? So our mass of 940 is 948 grams. So we can actually sub that into our variable m. So we have 948 grams right there. All right, next, do we have volume? Do we have that variable? So it actually tells us in a volume of 106.3 cubic centimeters. So units for volume, cubic meters and cubic centimeters for solids. So our piece of copper is a solid piece, and we have 106.3 cubic centimeters. So that's how much space that copper is taking up. So we're left with 948 grams over 106.3 cubic centimeters. So now we're just going to calculate it out. So we're just going to take 948. So I'm plugging that into our handy dandy calculator, divided by 106.3. And I got 8.92. 8.92. Let's make that decimal a little bit there. All right. Now we got to get a unit on density. So what are some units for density? So units for density is always mass per volume. So over here, and I'm going to switch colors right about now. So if you notice, the variable on the top or the numerator is grams, So we have 8.92 grams, and then the unit on the denominator at the bottom is cubic centimeters. They don't cancel each other out. They're still there. So we're going to have grams per cubic centimeter. Oh, that's a lovely 3. Per cubic centimeter. So our final answer for this, the density of our piece of copper is 8.92 grams per cubic centimeter. Okay, that was problem 1. Let's go to problem number 2. Problem number 2. Got another density calculation problem here. Oof, big surprise. There is 50 milliliters of ethyl alcohol in the beaker. If the density of ethyl alcohol is 0.789 grams per milliliter, what is its mass? Okay. All right. So again, we are just going to write out our density formula. So density equals mass over volume. Do we have our density? In this case, we do. So before I continue, there's 2 things you could do, right? So one is you could just start plugging the numbers in right away. Or 2, you could rearrange your variables to have the missing variable by itself and then the other variables together. I'm going to go ahead and just plug them in, but whatever way you feel comfortable with, because either way you're going to have to rearrange them, do it that way. So do we have our density? We do. So our density, they told us, is, and we also see grams per milliliter. So that's going to be an indicator. That's going to be our density. So we're going to plug in 0.789 in for the density variable. Do we have our mass? No, that's what we're looking for. So we can't plug in anything for that. So I'm just going to put mass again. But we do have our volume, right? So milliliters. So milliliters is a unit for volume. So is liters. And that's when we're dealing with liquids. So how much space is our ethyl alcohol taking? It's taking up 50 milliliters. And let me put those units right there. All right, so we have 0.789 grams per milliliter equals mass over 50 milliliters. Here, we need to be able to get rid of something, right? So when you see this in math, we need to get rid of our denominator. So we are going to have to multiply both sides by something, right? So we're going to multiply both sides by a number. So if we want to get rid of a denominator, we're going to have to multiply by that number. So we're going to multiply both sides by 50. The reason for that is our 50 can cancel each other out. So now we're going to have the mass by itself on one side, And then we have 50 times 0.789. Okay, so this is a little algebra, trying to manipulate variables and canceling things out. So we're going to go ahead and plug in our calculator. 50 times 0.789. And we get our mass. And let's change colors here real quick. We get our mass to equal 39.5. All right, so mass equals 39.5. What's the unit for this? So units for mass, again, are grams, milligrams, kilograms. So for this, let's take a look back at our problem. We had milliliters here, and we had milliliters here. So if we had our milliliters right here at the top, and then if we had this as grams per milliliter, if you notice there's milliliters on the top, and there's milliliters at the bottom. So when that happens, we can cancel those units out, and we're left with just G. So we're left with 39.5 G as our unit. So 39.5 grams, which is going to make sense because grams is a unit for mass. So our mass for this ethyl alcohol is 39.5 grams. All right, problem number 3. And 4. Oh my goodness, pause the video and you try. All right, for this part, I guess I want you guys to pause that video, try these 2 problems. First one, try looking for the mass. Second one, try finding the density. So pause it. Hopefully you pause it. Well, welcome back if you did. So let's go ahead and put these 2 answers up here. And let's change colors for just one more time. Let's go with that yellow. So our density for benzene. So our density for, our mass for benzene, you guys should have gotten 65.7 grams. So if you got 65.7 grams, awesome job. And for the other one, problem 4, piece of granite. Okay, yes, granite, all right. Our density of granite should have been 2.58 grams per cubic centimeter. So awesome job if you were able to get that. All right. Hopefully you guys did awesome. I'm sure you did. All right. On that note,